So it is observed that when you are searching for any key element, then there is a possibility that you search for the same key element again. For example, if you have a collection of books in a shelf, that is your personal collection, you have searched for a particular book and you take out the book and read it, again you keep it back. What is the possibility that again tomorrow you will search for the same book? The possibility is high. So that's what in the search, the behavior of search is that when we search for something, possibility that we search for it again. Then when we are searching for 5, how many comparisons it has taken? Total 8 comparisons we had performed to reach 5, that is 0 to 7. Now if we are searching for 5 again, then what we want is it should be searched faster. So there are two options. One option is you can move 5 to the previous location, just one location. You can swap 5 with the previous element. So it will reduce by one step. So second time when you are searching, you have to perform one less comparison. Then again if 5 is searched, then again it will move. So every time whenever you are searching 5, then it will be coming closer and closer. Now 5 is moved here and 10 is moved here. So let us write like this, 5 and then 10. Now again if you are searching for 5, then 3 will go there and 5 will come here. So if you again search, it will again move closer. So you can move a key element which is repeatedly searched, you can move it one step forward. So this method is called as transposition. So that transposition you can do it here. If that key element is found, then you can swap that key element with a of I with a of I minus 1. And now your key element has index I minus 1. Then you can return I minus 1. So this one statement you can add inside search procedure. So if the element is found, so it is moving one step forward so that next time it can be searched faster. This is one method. Now second method I will show you. Second method is if you are searching for a key element which is found here after performing 8 comparisons, then once it is found, you bring it in the beginning. Swap it with the first element. If you are swapping with the first element, the next time when you are searching, it will be found just in constant time. So this method is called as move to front or move to head. It is also called as move to head. Move to front or move to head. So this is another suggestion or another guidelines for improving linear search. So here in this code, if the key element is found, then we can swap the element with index 0. And now the new index is 0 for this element. So 5 is brought here. Let us assume 5 is here and 8 is here. So the key element that we have searched is brought in front. So you can return index 0, that the element is at index 0. So this is another method. In transposition, the elements will be moving slowly forward, or if it is not searched, then it will be slowly moving back. This is how it behaves. Then in move to front, if the element is searched, then directly it is brought into the first position. Suppose now if you search for 2, then 5 will be sent on that index 9 and 2 is brought here. So we don't know where the present element like 8 will be thrown away. But the new element will be brought at that index. So then again this may be thrown away somewhere else if you are searching for some other value. In transposition, there is a slow reduction in the time taken for searching. And in move to front, there is a sudden reduction in the time taken for searching. Next time if you are keeping on searching, it will be done only in constant time. So that's all about linear search and in its analysis.